Hello, my name is Levi Smith, and I will be going over how climate change is affecting the U.S. Great Plains SOMs. What is an SOM? An SOM is going to be soil organic material. It is going to be referred to as SOM throughout the rest of this lecture. It's going to be a very quick one. SOM is comprised of two materials. In this case, for this lecture, we're going to be going over soil organic carbon, or SOC, or soil organic nitrogen. That's just how we split it up. But most of the time, I'm referring to it as SOM. Another key term that we have today is going to be climate change. Climate change is the process of the Earth's warming and cooling over time, measured through ice core samples typically found in Antarctica. This is just a little graph to kind of depict how we have some peaks, and we have some valleys, and we have some more peaks, and we have some more valleys, and recently, right around here, we started to peak out, and then we started burning fossil fuels right around the Industrial Revolution. So that was late 1800s around that, or mid to late 1800s time frame. And our CO2 emissions and greenhouse gases has skyrocketed since then. So what is a greenhouse gas? A greenhouse gas is typically CO2, methane, CO2 produced from burning fossil fuels, methane mostly from big farms and farming initiatives such as dairy industry and big industries such as that, but that is being mitigated. Basically just any gases that trap heat on Earth. So greenhouse, if you look at a greenhouse, it's going to be, a standard greenhouse is going to be, a plastic dome typically over a set of plants where it traps the heat and it traps the sunlight, it traps, a lot of the stuff you need to continue growing. So how does this affect the Great Plains? Well, it affects the Great Plains by lowering the amount of carbon that can be stored by organic material, i.e. plants on the Great Plains, which are typically grasses and grasslands, since the Great Plains are a grassland. So it hinders the amount of stuff that they can store. So right here we have something in the way. So right here we have SOMs on one side of our graph. These are just very simple, just to kind of give you an idea of what these are going to look like if you do take a look at them. So as our temperature increases on this side, we have SOMs that drop. So we have the plants that are dying off early in the summer. We have plants that are not able to grow very well in high temperature areas, like such as these grasses. They die very quickly if you get them too hot, which is currently what's happening. Is we are in a warming cycle. So as our temperature climbs, our SOMs go down. So, but with precipitation, the same thing. I should put that right there. So SOMs perform opposite when it starts to rain. And as it precipitates more, like during springtime when it rains more in the Great Plains area, we have an increase in SOMs, which kind of are our carbon and our nitrogen, our soil organic carbon and nitrogen. So as those increase, it can, as precipitation increases, our SOMs increase in the soil, and how we measure that is through soil sampling. So what we'll do is we'll take a drill and we will dig down just a little bit of a ways. This is approximately from here, from the top to the bottom, is only about 4 inches. So as we get about 4 inches down, we're reaching back down in like the 1900s level, which is right about here on this graph, right about there. I should have done that with a different color, but so right about there is where we run into the 1900s, where we kind of quit, we run into the E horizon, which is the farthest down we can get before we start running out of topsoil and start digging down into the loamy, kind of funky, sandy, silty, stony area of soil. And below there's several different layers, but we're only worried about this top 4 inches, so we'll dig down a little bit and find samples that were, more akin to the year 2000. Or if we dig a little bit deeper, we go back to 1980. We dig a little bit deeper, we go back to 1960. So these are just how the plants kind of just go. They die, they decompose, and they lay on top of the dirt. Then those new plants come, die, decompose, lay on top of the dirt. So as that constantly happens, it builds layer, 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 layer. And what's trapped in those are our SOMs. So our SOMs get trapped in kind of a layered kind of thing, and we can measure that. So we have SOMs that are probably higher in the 60s and 80s than they are in the 2000s and 2020 now. So as our SOMs decline, we can see that with temperature, that's how we got these graphs, is we see with temperature, SOMs decline, and we see with precipitation, it starts to climb back up a little bit. So if you look at SOMs on a graph for this, it would probably look like SOMs, so time moves on. Trying to write sideways is not my strong suit. So as time goes on, we have SOM. So we probably have more SOMs back then than we do now, and it's slowly starting to decline. So as time moves forward, this is plus, this is plus, this is minus. So as time moves forward, we are seeing a decline in SOMs in our soil. So as we move forward in time, we see a decline in our SOMs caused by climate change and the greenhouse effect. And we can see it a lot with mostly the carbon side of it. The carbon side of it, we see a lot of decline. We see a lot of declining SOMs, or SOCs in this case, so specifically SOC, which is carbon. We see a lot of decline. We see a decline in this, and we see a correlation with rising CO2, or rising temperatures, excuse me, rising temperatures, which then produce rising CO2, which are, the rising temperatures are produced by rising CO2. Or, excuse me, yes, so the rise in CO2 has caused rising temperatures, and those rising temperatures see a decline in SOC. And as for nitrogen, nitrogen's a little bit of a wild card. Nitrogen kind of does its own thing most of the time, but nitrogen is heavily influenced by temperature and rainfall. So the less nitrogen, so if we deplete nitrogen, we get less plant growth, less, well, I guess organic matter, organic matter. So we get less organic matter. The more we deplete our nitrogen, the less organic matter we have, meaning the less CO2 absorbed. So with less CO2 being absorbed by the Great Plains, one of our bigger carbon sinks, like the ocean or the rainforests, is we deplete our nitrogen in the soil, which is just by plants dying off, and we can't grow them as efficiently as, well, we as in the planet can't grow the plants as efficiently as they should. So with the lessening amount of nitrogen, which is pretty much a fertilizer for some of these plants, with the less nitrogen, the less plants grow. We see a decline in carbon sinking in the area, and these tests right here, these soil samples have been taken, all over the country, especially in the Great Plains, from Colorado to Texas to Montana to Wyoming to a bunch of the middle states in the United States. So just to kind of recap a little bit, climate change is affecting the Great Plains through SOMs, so by lowering the amount of SOMs that we have, stored by organic material, so the less carbon we can store, the less nitrogen we can store, the more this problem is going to increase. Then key terms, soil organic material, which is SOM, soil organic carbon, and soil organic nitrogen, which are two parts of SOM. Climate change is the process of the Earth warming and cooling, measured through ice core samples typically found in Antarctica. You can find more graphs that look similar to this online. Then the greenhouse gases in effect. So the greenhouse gases are CO2, methane, and I think a couple of other gases that really don't do too well in the atmosphere, don't do us a good thing in the atmosphere. And these are all gases that trap heat on Earth. So it doesn't let it expose back out into the stratosphere, and then from there on. So then we have our SOM graph of temperature. So as temperatures rise, SOMs come down. As precipitation goes up, or as it rains more, precipitation, our SOMs increase. And this is just kind of your topsoil. Just look up a topsoil horizon line, and it'll give you, or a soil horizon line graph. It'll give you organic layer, topsoil, E horizon, and then so far down but these are the only two we're really worried about, is the organic and topsoil layer in this thing. So then, as SOMs go on, as time goes on, and we continue experiencing an increase in greenhouse gases, I guess it could look like that. As we experience an increase in greenhouse gases, we see a lowering amount of SOMs. So I do want to take a minute and thank give a big thanks to the Journal of Soil and Water Conservation. They did a fantastic job of publishing this and making it very legible. I want to thank them for that. The 4 authors of this paper were R.F. Follett, C.E. Stewart, E.G. Pressner, G.M. Kimball, and I want to thank you all for your time today. I greatly appreciate it. I hope you have a good rest of your day, and I hope I taught you a little bit something about how climate change works and how SOMs work. So please, have a good day. Thank you.